Okay, so this lesson is about experimental versus theoretical probability. So first we need to define what we mean by the two and what the difference is among the two. So experimental probability is what happens by actually doing something. So tossing a coin, spinning a spinner, throwing dice, etc. Okay, so experimental probability is probably based on performing an experiment. Okay, by experiment we mean, for example, you toss a coin 40 times and observe 24 tails. Therefore, the experimental probability of a tail based on the 40 tosses, of course, is going to be 24 out of 40 because your successes, when you define success as tails, 24 out of 40, which is 12 out of 20, 6 out of 10, or 0.6. Okay. So theoretically, what should happen when you toss a coin, you should see a 50-50 ratio between heads and tails. Half the time you should see a head, half the time you should see a tail. But theoretical probability, so let's just write theoretical probability is based on what should happen. Okay? So on paper, there's a 50-50 chance of getting a head or a tail when you toss a coin because there's one head out of two possibilities, same thing, one tail out of two possibilities. But that only happens when we repeat the experiment over and over and over again a large number of times. In our experimental probability here, we only tossed the coin 40 times. So we should see 50-50 ratio. We saw a 60-40 ratio, which is significantly off, but it's not like, 90-10, 80-20 ratio. So theoretical probability is what should happen in long run. Okay. In the long run, when we toss a coin, let's say 1,000, 10,000, 100,000 times, we should see really, really close to that 50-50 ratio between heads and tails. Okay. So theoretical probability is, again, just what should happen. So when tossing a fair coin, not like a trick coin or anything like that, what we should see, the probability of getting a tail is 1/2 or 0.5, of course. Okay, and what we were just talking about before is the difference between theoretical and experimental probability as we repeat our experiment over and over again. So again, we toss the coin 40 times, we saw a 60-40 ratio, but if we toss the coin 1,000, 100,000, million, 10 million times, whatever, we're going to get really, really close. It might not be perfect. It probably won't be perfect. But we're going to get really, really close to that theoretical 50-50 ratio. So that's called the law of large numbers. Law of large numbers says as the number of times we repeat an experiment increases, so as we go from tossing the coin 40 times to maybe 40,000 times, we will get closer and closer to the theoretical probability. Okay, let's take a look at how we use this in a question. So the spinner below shows 5 equally sized slices. Susan spun the dial 1,000 times and we got the following results. So this table shows you her results. She got a white 378 spins, gray 425, black 197, and this is out of 1,000 total spins. Okay, so assuming that the spinner is fair, compute the theoretical probability of landing on black. So theoretical is asking what should happen. okay, not what actually happened. So we're going to ignore this table. What should happen is one of the slices is black out of 5 total. So the theoretical probability is 1 out of 5, or I'm not sure if they want the answers as decimals. If they do, that's 0.20. Okay, from Susan's result, so now we're going to be using this table. Compute the experimental probability of landing on black. So she got 197 spins on the black out of 1,000 total. And if you go to your calculator, that's 0.197. Okay, so 1,000 spins, pretty decent amount. We got really, really close. It's just 0.003 off from the theoretical probability. Okay, assuming that the spinner is fair, choose the statement below that is true. The larger number of spins, the greater the likelihood the experimental probability will be close to the theoretical probability. Yeah, that's what we were saying with the law of large numbers. The more we repeat the experiment, the closer and closer we get to the theoretical probability. Let's look at the other two choices. The experimental probability will never be very close to the theoretical probability, no matter the number of spins. That's false. Okay, we said as we repeat the experiment more and more into the thousands, 100,000s, whatever, we are gonna get close to the theoretical probability. Okay, so that's false. And the smaller number of spins, the greater the likelihood the experimental probability would be close to the theoretical probability. That's false. It's not the smaller number of spins, it's the larger number of spins. Okay, let's take a look at another. Again, we've got a spinner with 5 equally sized slices. She spins the dial 500 times, and we get these results. All right, compute the experimental probability of landing on white. Okay, so we want, it says experimental, we want to use this table. So we have 197 white slices out of 500 total spins, and when you get a decimal on that, let's go to the calculator. That is going to be 197 over 500.394. Assuming the spinner is fair, compute the theoretical probability of landing on white. So theoretical, this is what should happen. We're going to ignore the table. We're just going to look at the spinner. So we've got 2 white slices out of 5 total, which as a decimal, 0.40. Okay, assuming the spinner is fair, choose the statement below that is true. Smaller number of spins, the greater likelihood that the experimental probability will be close to the theoretical probability. No, that's false. It's the larger number of spins. The experimental probability will never be close to the theoretical probability no matter the number of spins. That's false. So the larger number of spins, the greater the likelihood that the experimental probability will be close to the theoretical probability. Yes, that's what we were saying with law of large numbers. So that's the true statement.